So I'm Stephan Brink, CEO and co-founder of ManusVR. ManusVR was also represented in the last slide, just quickly. We make data gloves that enable to interact intuitively with VR, for example, but there's also some other use cases. I will co-present this presentation together with Wenk. He's from Lightshape, and he can probably introduce himself best.
Yeah, thank you. Yeah, welcome at the DIGILITY. My name is Wenk, and I'm a CEO and co-founder at Lightshape. There we're working since 2012 for, let's say, professional marketing experiences in VR. And later on, we started adding engineering functions, which means for us that we are basically scouting for new solutions on the market, which means hardware and software. We are analyzing it, we are combining it, and if necessary, we just modify it just to create the best solution for our clients. So that's what we do.
So that might also explain a little bit about the reason why we do this presentation together. We are more focused about tracking stuff, actually. So a lot of the presentation, the previous presentation was also what I will be telling. So the title of our presentation is How Will We Work in Virtual Space? So we won't be talking about what are the benefits. A lot of topics have already been passed in the last decades. But it's more interesting to, let's see how we make that virtual space, that virtual workspace. And I first want to start to think about how should it look like in the future? What's the ideal situation? I hope you see the reference with Ready Player One, the picture. It's Percival sitting in his feedback chair and he is completely immersed in his virtual world. So a virtual workspace to us should be able to connect to different devices. You should still be connected to your smartphone, to your laptop, to your AR device maybe in the future, to your tablet. And so you can have multiple people together in a joint collaborative workspace. So some engineers might be on their tablet, and some might be completely immersed in VR. Others will be seeing it through AR and have a combined mixed reality experience. The next point is that you should also be able to interact intuitively with that VR environment. And it should be integrated within the company network. That means that, for example, you can download directly 3D models from your cars, for example, or parts that you just designed, and immediately start working and testing it in the workspace. At this point, you still need to hand-make it completely from the ground up. The second point, the fourth point is collaborative multi-user. So you should be able to work together with multiple people in the same workspace. And a big issue with that is that you also should be able to identify the other people around it. So you have to see their avatars, and they have to represent it accurately to who they are. And the last point, that will be very interesting, and we probably still need to learn a lot about what the possibilities are, because when you're working in virtual space, you also track a lot of data. And that could, of course, lead to big data, and that could lead to big best practices for certain engineering stuff, or medical treatments, etc., etc. So what's possible now? We will talk about what kind of tracking solutions there are now. The previous presentation was a little bit going into that depth. What feedback there is, interactive environments, natural and intuitive behavior, multi-user and system integration, and the last point is avatar creation. So tracking. Absolute position within space is one of the most important things. The most HMDs are already coming with it. We are a big fan of the HC5 with the lighthouse tracking. It's very accurate and easy to set up. There are other systems around like the Vicon or the markerless tracking I just learned about. A big issue as well at this point is locomotion within that space. The tracking areas are still fairly limited at this point. Body tracking, that if you want to have full awareness, you need to have your full body tracked in space. And the problem with that is that you need to align the digital avatar to your own body, because that's the problem with inverse kinematics. If you see your hand, you know where your hand is, you want to be able to touch it. And so it has to be really accurate if you do that, because if you do it wrong, it doesn't feel right. Well, hand and finger tracking, that's our kind of specialty. There are different solutions for it. Gloves is, of course, the thing we're making, but you can also do it with optical tracking. Facial tracking is still in the very early stages. We now see eye tracking coming on the market. Fove is one of the first headsets to integrate it. And I think Samsung just revealed another one with Fove-feeded rendering. But in VR space, you also want to see the expression of the people you're working with. Facebook did a great presentation with social VR, where you could see people smiling and certain basic interactions. The last one is spatial awareness. You should, of course, know where the limits are of your tracking space, or where your other people or multiplayer persons are in the same space, so you don't bump in them. This is a short video about one of our partners that are doing a multiplayer setup using IMU suits from Xsense in combination with our gloves. And they're all working together, and it's live streamed to another device, a tablet or a big TV screen. And it's being used for esports. So you can directly stream what is going on in VR to a big screen in a stadium. So feedback, this is one of the most difficult things we're now investigating. So there are a lot of ways to getting feedback. Visual feedback is, of course, the first thing you get in VR. But the other things that are more physical, like touch, force, pressure, texture, weight, temperature, even pain, yeah, they're all part of being immersed. And we did a lot of research into this topic. And at this point, it just comes down to that if you want to have those real feelings, it's best to use tracked props. An example of that is in the picture, right, of left to the text. And you see we're using the Vive tracker on a golf club. And with that, you get the right feeling of the object. This is also represented in VR, so you can actually swing in VR and have that exact feedback. This is another example of where feedback really matters in a VR simulation. This is a training simulator representing a Chinook military helicopter, where they are training military medical personnel for treatments. And in this case, you just couldn't use controllers. They need to be able to reanimate the bodies and have a real feeling for the environment. Another topic is making the environments with physical interaction. So if you're making a VR environment, it's really it takes a lot of time to actually build it, but then you just have the environment, and you can just look around, maybe walk around. But to naturally interact with that environment takes it to another level, especially if you take into consideration that when you're using your hands, you are colliding with 3D objects, and are most of the time not made for that. So it takes a lot of time to interact with that. It's a short video we made. This is what we're now working on the software level. You can see that we are using colliders and interacting with specific objects and combining it intuitively with grasping motions. So I'll give the word to Robin.
All right, thank you, Stephan. Yeah, all the examples that we've seen before now, they're just heading into one direction, and that means that we all want to have natural and intuitive behavior. If we are working in VR, it feels quite natural. It feels almost like reality. And the next logical thing is that anything in this world would react just natural as we're used to it. And there's some important components that comes with it. It's, for example, freedom of movement, so you don't want to have limitations. Of course, people at home, consumers, they still have at least limitations with their walls. Even in the industry cases, there are always walls that are limiting you somehow. And the next thing is freedom of interaction. That was what Stephan just wanted to point out right now. So acting with objects, usually if you incorporate those ones into your scenes, they're dumb by nature. And to make there some logic into it, that takes some effort. If you're working in the industry, so there might be some repetitive tasks that you can use, and then you can give them some kind of logic, but it's still a quite challenging task. And the next thing, of course, is, so we're social people, so we like to interact with each other. So that means also interaction among people, because if you're working, usually they're collaborative experiences. And that's what we work usually every day. Yeah, that brings us to the multi-user. The scheme that you see here in the back, that is not actually in the future, that is just that we're having right now. That's basically a current state of thing that you have some kind of a tracking. It might be optical, it might be infrared, or something that you need at least to track the position. And currently you still have, at least in the industry, some kind of a backpack that you're using. There are some options right now appearing on the market, so those are just obstacles that we will overcome in the near future. In the engineering, it might take maybe just a little bit, at least for large-scale setups. So, yeah, while the hardware probably is changing, one thing or one component that will be persistent, that is the software. You will need some kind of software, some middleware, which is connecting all the users to each other. And of course, you need to monitor them somehow. From our experiences, if we have large-scale setups, there is always something that can go south. And that's a terrible thing. So if there are a lot of people in there and they have, usually they're kind of important people, they have less time, and that means if something goes wrong, you need to be able to fix it somehow quickly. And that usually means you have to have some monitoring. Usually you have to have some kind of a master in the scene, or let's say a presenter, who just guides those people. In the near future, if we become a little bit more like Tony Stark, we will have sometimes, or someday we will have some Jarvis who might help us, or some kind of an AI. But we'll leave that up a little bit up to the future. And yeah, one interesting thing, if you are working in room scale VR, you're used to teleportation quite a lot because you're limited in your space. If you're working in teams together with a lot of people, you should be quite cautious with those ones because there is always the presenter, the master who has control over the scene, and he can teleport as much as he wants to. But all the other ones, they get confused with that one. So they need to be somehow prepared, and it should be some kind of a transition in between that they are prepared. And yeah, the next thing about, if you're talking about multi-user, I just showed you an example where you are physically in the same space. The next thing is just to connect those ones. That means you can invite either into big spaces little setups like HTC Vive or like an Oculus or maybe a HoloLens or whatever. And you should be open to those systems in the future. It might be just a smartphone or something. It's not the most wanted option that you want to have in there, but you can't exclude those users. They should be able to take part. And yeah, so it's quite a challenging thing to pull all those things together, especially if you need to add some more hardware, because that will steep up the thing exponentially. And if you have mastered all those things and you want to implement that in a big firm, of course you have to face the reality of security protocols, and that will just pull you back quite a bit. And there you need to find somehow a thing where you can, where you don't want to cut down usability too much. Yeah, interaction. An important part of those are definitely the avatars. The screen that you are seeing now in the back is something that we worked in, I think, early 2015 with the avatars, so they were really, really basic. So the only thing that was tracked were the heads and the hands. And those are actually the major attributes that you want to implement. And of course, like Stephan said, you need to be able to identify the others. If they are physically in the same space, you might recognize them by voice. If they are somewhere on the internet connected with your setup, you need to have at least like a profile name, that's the easiest way, or a profile picture above the head. And of course, if you look a little bit more in the future, you would love to have some 3D scanning. There are already high-end solutions out there. But they're quite expensive, and not only that, I just see them in research labs. I don't see it in firms already, because it's not only the budget that you need to have for those ones. It takes a lot of time to build those avatars. You need to scan those people, and in reality, a lot of people are not flexible enough to do that. If you have a real pipeline in the future for that one, you will have some kind of an avatar, and you will just load it onto that one, and it will pop up immediately. Yeah, but let's keep it for now. And here's actually a scheme which is quite similar to what Facebook Spaces showed, and I totally agree with them. If you're not able to track everything in the scene, don't show anything that you can't really track, because it will mess up the immersion. If they're not in the same space, it doesn't matter that much. But if you're physically at the same space, it's better to have like a real tracked representation of the other ones. That would be preferable, because you kind of sense that there is a person which doesn't match with the avatar that is in front of you, and that makes you a little bit more cautious. So you don't want to get too close to those one, because you tend to bump into each other, or at least to touch each other. It hasn't been a real issue in the past, but it's really something that you want to avoid. And you're facing some challenging effects. The uncanny valley probably everybody knows in here, so I don't want to go into that one too deep. The Proteus effect, that basically means that if you are able to modify your avatar somehow to make him look better, to make him look taller or whatever, it will have a certain influence on your opponent in the scenery. And of course, that will give you some advantage. And as humans are, if there is an option for getting an advantage, usually they tend to take that one. And yeah, that opens other, like, more ethical questions. So how would you want to limit that? Well, yeah, we'll see how this will turn out in the future, and you will have some privacy issues as well if you want to implement that one in a firm. Yeah, we kind of heard a little bit about interaction and object manipulation. The more precise it can be, the better it is. There are a lot of cases, like in marketing, where we like to work with motion sensors, but for the engineering, if you want to be really precise, and if you have like a feasibility study or a packaging or trainings, it really is required that you work precisely. And there, for example, is of course one solution to have a very precise glove. So I'll show you a little video. That's actually the demo that we're having up in the booth down there. So you are absolutely invited to come down there and check it out a little bit. Yeah, as you see here, it's not really an engineering case that we're showing here. That unfortunately is not really possible. But yeah, you kind of get the point how you can interact with some objects in there. Yeah, I think we're probably already over the time.
I'm not sure what the time is now.
So, yeah. Oh, we do.
Okay.
Oh, okay.
Okay,
So that's nice. So then we have some question time.
Yeah.
Well, yeah. Any questions?
Any questions from the audience?
Any questions? Are you sure? No, don't be so shy.
All torn down.
Okay. Are you sure? Okay, I have to tell you, you should try that out. I tried it, and I really had a look on how accurate this is working and how fast this is tracking my fingers. And I have to say I'm impressed. So that, that is really helping. And I see in your presentation there is a lot linked to what Niels is doing. When you're saying you want to see the whole body, now he has a solution. So
and
I
what
guess
I also saw in Niels' presentation is that he had the body, but not the hands yet. Indeed.
Yeah, so that's what I was saying. You might have some collaboration options there.
Exactly.
Okay. There is one question. Can we have a microphone? It's in the further back, please. Yes, there's a microphone coming. Yes, just raise your hand. Fantastic, thank you. Yeah, exactly. I'm like,
Hello. I apologize if I missed this in another talk, but I'm interested because we're talking about a lot of explorative territory. You mentioned the idea of having or bringing with a customized avatar into a digital space or into a virtual reality environment. Is there any discussion or exploration of kind of like web standards, virtual reality standards, so that, you know, the avatar that I build in one environment I could bring into another environment, or will they all be speaking the same language, the different environments, to each other? Because then it feels like I would be having to customize and create a new avatar for every space, like with every digital product I do today, which is kind of aufwendig. Yeah.
Well, shall I answer? Yeah, well, first of all, to getting a scan as, for example, an FBX model or something, to implement that one and to get the IK with that if necessary, that is not really the issue. But of course, on the other hand, you need to have some kind of application which answers to that basically immediately. And standardization, that is a thing that we all are probably hoping for a lot more in this industry, because technically there are a lot of solutions out there that works as a prototype already, but they have no standards, and so they don't really work together yet. So we're there a little bit in the transition now.
I can also give you an answer to that. In my normal day-to-day job, I'm working for Fraunhofer Heinrich-Hertz Institute. So we have a couple of activities in the MPEG OMAF, that is the standardization body, MPEG, that's a Motion Pictures Expert Group, and they have one part that is dedicated to omnidirectional standards. And then there is the Virtual Reality Industry Forum, and they just formed CES this year, and they're trying to bring standards forward. But that is a really strong and intensive topic. You have to bring everybody to the table, and it's almost as complicated as the standards for television and so forth. There are 30 to 60 companies who all want to get their ideas into that standards, and everybody has to collaborate. But on the other side, there's a lot of politics. So I can tell you, people working on standards, it just takes a bit of time.
The risk is really there, because imagine if somebody else takes your appearance and just shows on, for example, in VR.
I can also tell you tomorrow I'm giving a presentation of what we are doing, and there is volumetric video involved, and that's not scanning, but 3D human body reconstruction. So that is basically creating models out of cameras, out of this capturing in 360, reconstructing from 48 cameras or more. So I can show that tomorrow. That's kind of scanning.
We're going to be there.
Thank you. Perfect. Fantastic. Thank you so much.
Thank you.
See you later then for networking.
Yep.
Thanks.
Thank you.